this is Anamir, and today we're going to be discussing molecular versus ionic versus non-ionic equations. So if you're wondering what all those words mean, we should first look at our question so we have an idea why and when do we use these equations. So the question says, right, part A says a molecular equation, B says an ionic equation, and C says a non-ionic equation of the following reaction. Now, usually in the exams and stuff, they don't give you the whole reaction. You're given reactants and their states, and you're supposed to use your solubility rules, to figure out what the products and their states are. But here, because I'm teaching you how to write these equations, to make it easier, I just wrote out the whole reaction for you. Thank you later. Okay, so first, part A says write a molecular equation. So now it's time to see what it really means. The molecular equation is a balanced chemical equation in which ionic compounds are expressed as molecules instead of component ions. Now, what does that really mean? So if you have, if you can see, we know that there is a formula for each ionic or whatever compound. Whenever we write chemical equations, we need formulas for that. So we know that barium chloride here is BaCl2. We have that memorized. I'm just going to write out the whole equation here. We know that it produces, which means we have to put an arrow here, sodium chloride, which is a solution, like aqueous, same thing, and barium sulfate, which is the only one solid here. Okay. Plus sign. Okay. So for a molecular equation, we know from the definition that it has to be balanced first. Well, any equation you write, any chemical equation you write, 99% of the time, you just better balance it, because, so here we know that we had 2 sodium and 2 chlorine, so we put a 2 here, so we balance the equation. So now we have the balanced equation. Now we have to check if we're good with this equation. A balanced chemical equation, so we have the balanced chemical equation in which ionic compounds are expressed instead of component ions. So we know that these compounds, they're ionic compounds, but we express them as molecules. They're one unit. So at this point, we're good with our molecular equation. So let's move on to the complete ionic equation. And the reason why I wrote the word complete here, you may see that there's no complete in here. It's the same thing as an ionic equation, but if you write complete or if you memorize it as complete in your brain, you're going to be able to differentiate it with a non-ionic equation. So first, we should read the definition. So the definition says, a balanced chemical equation in which electrolytes in an the electrolytes in an aqueous solution are written as dissociated ions. Now, what does that mean? If you see, I highlighted the word dissociated here and the word molecules here, because those are two different things. The ionic compounds that are electrolytes in aqueous solutions, we're going to break them apart. In here, they're a unit. In here, they're an. On the molecular equation side, they're a unit. On the complete ionic equation, they're not. So what that means is that anything that is an electrolyte in an aqueous solution, we got to break it apart. I separated them so you can see how they're independent of each other. They don't depend on each other anymore, and they're just separate ions rendering in the aqueous solution. So now, obviously, we balance the equation. That means we had 2 sodiums here, so we put a 2 here, 2 sodium ions. Similarly, 2 sodium here, 2 chlorides here, and 2 chlorides on the product side. So what this means is that by this time, we have at this point, to separate by this line, we have written At this point, we have written a complete ionic equation of the reaction given above because we separated them, we dissociated them into their ions, whichever ones were aqueous and they were electrolytes in an aqueous solution. And we want to see the participating species for the final reaction. We can get rid of the ones that are not participating. So if you were to do if we were to transform this complete ion, that's why it's called complete, because it has all the ions. If we were to transform this one into a non-ionic equation, we would do, okay, we will look at the reactant side, which is like above the arrow. We see 2 chlorides, and we see 2 chlorides here. We see a barium here, but we don't see a barium ion here. This barium, the barium inside this barium sulfate, it's committed to barium sulfate molecule, and you can't do anything to it. So that means that it has to stay there. It doesn't have a partner in the product side to take it away. So if we were to write it out again here, we would write, so if we were to write this equation out again here and make this a complete ion equation, so if we were to write them out differently, so if we were to write them out separately, we would know that the non-ionic equation, getting rid of all the species that are not participating, we would only get barium plus sulfate that we already talked about.